In Lesson 3.2, we're going to learn how to solve systems of equations using either the substitution or elimination method. So your essential question is, how do I know which method is best when solving systems of equations? So first let's take a look at the substitution method. The substitution method is when you know that one of the variables is equal to a specific thing, you can plug that into the other equation. So, for example, if I have the system of equations y equals 3x plus 4 and 2x plus 3y equals 10, then I know what y is equal to. It tells me that y is equal to 3x plus 4. So therefore, I could take 3x plus 4 and substitute that for y into the other equation. And then I could solve for both x and y. Also, similarly to that, if I had x equals 2y minus 7, and then I had 3x minus 6y equals negative 12, I know that x equals 2y minus 7. So I could take what x equals and I could plug it in for x into the other equation. So if I know one of the variables, then I can plug that value in for that variable into the other equation. And that is substitution. So we're going to solve this system of equation using the substitution method. Now, if you look at this, you should notice something different. In both of these examples that I gave you, I knew the value of y, and in this one I knew the value of x. In this one, I do not know what x or y is equal to. So what I need to do is I need to solve for either x or y in one of the equations. Now, if I take a look at this, I notice that this x right here is pretty much by itself, except for this 3y. So if I just move that 3y over, then I will know what x equals. So what I'm going to do is I'm going to solve for x in that equation. So I'm going to subtract 3y from both sides. And then I get x equals negative 3y plus 3. Or you could write 3 minus 3y. It does not matter. So from here, I know that x equals negative 3y plus 3. So I'm going to take that value and I'm going to plug it in for x into my other equation. Now I like to actually put a circle or a box around what that equals and draw where I'm plugging it into to make it less confusing. So from here, I would take 2 and instead of x, I'm going to write in parentheses negative 3y plus 3 plus 5y equals negative 5. So from here, I just need to solve this equation. So I'm going to distribute. So I get negative 6y plus 6 plus 5y equals negative 5. So now I can combine like terms. Negative 6y plus 5y equals negative 1y plus 6 equals negative 5. And then I can subtract 6 from both sides. So these cancel out. And I get negative 1y equals negative 11. So if I divide by negative 1, sorry, that should be negative 1, then I get that y equals 11. Now, am I finished? No, because remember when we graphed systems to find the solution, you have to have something for both variables. The point where the two lines crossed was the solution to the system when we graphed. So I have to have both an x and a y to know the solution. So if I know that y equals 11, what can I do with that to figure out x? Well, really, you could plug that back into anywhere. You could plug that back into one of these original equations for x, or for y and then solve for x. Or, since I already solved for x down here, I find it simpler to just plug it into this one. So if I know that x equals negative 3 and y equals 11 plus 3, then that would be negative 33 plus 3, which would equal negative 30. So I need to write my solution as an ordered pair. So the solution to the system would be x and then y, negative 30, 11. And again, that's your x and your y. So this is what I would want to see as the answer. Okay, now that is the substitution method. Now let's recap really quickly what the steps were that we took to solve that system using substitution. So first, you have to try to get either x or y by itself in one of the equations. Step 2 is to plug in what the variable is equal to, and then take that and put it into the other equation. Step 3 was once you have the solution for one of the variables, you plug that back in to one of the equations and solve for the other variable. And then the last step was to write your answer as an ordered pair, like x comma y. So what we did was we found what x equals. We plugged that in for x in the other equation. We solved for y. Once we got y, we plugged that back in and we solved for x. And then we wrote our answer as an ordered pair. So that is the substitution method. Now, my personal favorite is the elimination method, but there are advantages to using each method in a different situation, so it just depends on what you have. I find that the elimination method works best when you have everything lined up, for instance, in standard form. So let's say I have x plus 2y equals 10, and then I have 3x plus y equals 20. So then, if I want to eliminate something, eliminate means that you're canceling something out. So this is when you're solving a linear system, you have to cancel out one of the variables by adding the equations together. Now if you look at this example, I cannot add them together vertically and cancel anything out. But if I had something like this, like if I had, oops, sorry, if I had y plus, let's try a different one. If I had x plus y equals 10 and negative x plus 2y equals 20, then if I added the equations together, the x's would cancel out, and then I would get 3y equals 30. So if I divide by 3, then I would get y equals 10, and then I could just plug that back in and figure out x. Now, for this example up here, though, my x's don't just cancel out like that. It's not very nice. So what I can do is I can look at either my x's or my y's, and I could say, how could I change this equation on top so that my x's would be able to cancel out? So if I look at this one, this is a 3x. For this to cancel out, I would have to have a negative 3x up here. So what I could do is I could multiply this entire equation by negative 3, and then I would get negative 3x minus 6y equals negative 30. And then I could add these two equations together, these two now, and get an answer. So sometimes you have to manipulate your equations a little bit in order to do elimination. So let's take a look at the example they want us to solve. Solve the system using the elimination method. So if I take a look at my equation, okay, I have 3x and 6x, and I have negative 7y, negative 8y. If I add these together, none of them will cancel out. So there are some options. You choose which variable you want to cancel out. So you can choose to cancel out the y's, or you can choose to cancel out the x's. I'm going to choose to cancel out the x's, because if I look at this, what would cancel out 6x? Negative 6x. So how do I turn this 3 into a negative 6? Well, I would multiply that entire equation by negative 2. And when you do this, you have to multiply it to all three numbers. That's a really big thing. So therefore, I get as my new equation negative 6x plus 14y equals negative 20. So now I no longer have this equation. I have this equation down here. If I add these two together, the x's will cancel out. Then I have negative 8 plus 14, which would be 6y, and 8 plus negative 20 equals negative 12. So then I would divide by 6, and I get y equals negative 2. Am I finished? No, because remember I have to have both my x and my y. Now you can take the y equals negative 2 and you can plug that into any equation you want. You can plug that into the new equation you got, you can plug it into the old equation or this equation, it doesn't matter. I'm going to plug it into the original one right here that I had before. So I had 3x minus 7, and then now I know that y is negative 2 equals 10. So I get 3x plus 14 equals 10. So I subtract 14, and I get 3x equals negative 4. And so then I divide by 3, and I get x equals negative 4 thirds. Now I want to make sure that I did that right. So what I can do is I can plug that in, my negative 4 thirds, negative 2, and make sure that that is correct. I'm going to go through and check really quick and make sure I did everything right. So if I multiplied this, negative 2, I got negative 6x plus 14 equals negative 20. And if I add these together, these cancel out. Aha, I found my mistake. Nope, just kidding. I thought that was negative. It's not. So that would be positive 6, negative 12, so negative 2. 3x plus 14 equals 10. Okay, it looks correct. So let's double check our answer by plugging it back in. So if we plug it back in, then I should take 3 times negative 4 thirds for x minus 7 times negative 2 equals 10. And that should work out. So if I take 3 times negative 4 thirds, then I get negative 4 plus 14 equals 10. And that checks. Now it has to work for both equations. So if I take 6 times negative 4 thirds minus 8 times negative 2 equals 8. That should also work as well because it has to work for both of these equations. So if I do this, I get negative 24 divided by 3 would be negative 8 plus 16 equals 8. So that is true. So it does work. So my solution is negative 4 thirds, negative 2. So do you see why this method would be better than if I graphed it? If I tried to graph these two equations, first I would have to solve for y in both equations and then graph them. And then the point where they cross is the point negative 4 thirds, negative 2. And that would not be very easy to see on the graph. So that is one reason why the elimination method is good to use, because you can get an exact answer and you can check it and know that it's right. So let's recap really quick on the steps for those in case you want them. So the first step is you have to multiply one or both of the equations by a number so that the x's or the y's will cancel out. And occasionally you'll get so lucky to where you don't have to multiply anything, kind of like in this example that I showed you up here. If you don't have to multiply them because you can just add them together and cancel out, then you don't have to do that step. But most of the time, you will have to multiply one or both of the equations by a number so that you can get something to cancel out. Then you'll add the equations together and solve for one of the variables. So we added ours together and solve for y. And then you'll plug that into one of the equations and solve for the other variable. And then the last thing is that you have to write your answer as an ordered pair. Okay, so let's try a word problem. So to raise money for new football uniforms, your school sells silkscreen t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8 each. Long sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? So, whenever I have word problems like this is a lot of information and it's all important information, and I have to somehow organize all of it. So, the first thing that I like to do is I like to assign variables and write equations for each thing. So, let's look at what we got here. Okay, we are selling t-shirts. We've got short sleeve t-shirts and we've got long sleeve t-shirts. So I kind of need variables for each one. I'm going to use X to represent the short sleeve t-shirts and Y to represent the long sleeve shirts. Now, you could use S for short sleeve, L for long sleeve. It really doesn't matter. You just have to pick a variable and stick with it. Okay, now we have two different situations going on right now. We've got buying shirts, the school that we're spending money on ourselves as an expense, and then we've got what we're making off of the shirts and what we're selling them for. Okay? So I know that the short sleeve t-shirts cost $5 each. Okay? And the long sleeve t-shirts cost $7 each. So I would have 5 short sleeve, which is 5x, and then I have 7 long sleeve, which is 7y. And how much did it cost me to buy all of them? Well, the school spent $2,500 on what they were buying. So that's going to equal 2,500. Then I have how much that we're selling them for. So the short sleeve t-shirts are selling for 8 and the long sleeve t-shirts are selling for 12. So I would have 8x plus 12y equals 4,200 because that's how much we sold all of them for. And we need to know how many short sleeve t-shirts we sold. So looking at this system of equations, which method do you feel like would be easier to get x or y by itself using substitution, or should we like multiply one of the equations or both the equations and do elimination? Well, it's kind of up to you, but I feel like it's really easy in this situation to get um, both of these equations, like the x's to be the same number or the y's to be the same number, and use elimination because both of these equations are written in standard form. So I could easily just multiply this one, and then add them together and go. Um, Sometimes when you choose to do substitution, like I would have to get like either x or y by itself, and it might come out to be a fraction, and that might be really messy to deal with. So I like to use elimination when the equations are both in the same form. So I'm going to multiply the top equation by -8 and the bottom equation by 5 because I could get both of these to equal 40. So I'm going to multiply this one by -8 and this one to be by 5. So this is -40 and this is +40, and then they'll cancel out. So I would get negative on the top, I would get -40x plus or minus 56y equals, and then I have to take -8 times 2,500, which is 20,000. So -20,000. Then on the bottom equation, I would get positive 40x and then plus 60y equals, and then I have 4,200 times 5, which is 21,000. So even though I have big numbers, when I add these together, it's not going to be so hard. So these cancel out, and then -56 plus 60 would be positive 4y, and then I have -20,000 plus 21,000, so that would just come out to be 1,000. Then I would divide it by 4, so I get that y equals 250. Now, Y represents the long sleeve shirts, and the question wanted to know how many short sleeve shirts were sold. So I need to plug this back into any of the equations. I'm going to plug it into this original one here. Doesn't matter. So I'm going to have 5x plus 7 times 250 equals 2500. So 7 times 250 is 1750. So I get 5x plus 1750 equals 2500. And then I would subtract 1750 from both sides. So 2500 minus 1750 is 750. So I get 5x equals 750. And then if I divide both sides by 5, then I get that x equals 150. So x represents my short sleeve shirts. So I sold 150 short sleeve shirts. So if I go back up, my answer would be C. Okay, so you need to go back and answer the essential question. How do I know which method is best when solving a system of equations? Remember that you need to chunk your notes into sections after you've taken them and also to summarize.